Okay. So if we did another study where we just said, okay, these people drive Mercedes-Benz, these people drive cheap cars, and if we looked at these two groups as a whole, we would see the people with the cheap cars, in general, this is a true statement, would have more health problems than those who drove the Mercedes-Benz. Does that mean driving a cheap car is hazardous to your health and the Mercedes-Benz is good for your health?
No.
No, what's going on there?
There's socioeconomic status.
Yeah, we have different social classes here, okay? And this isn't even a causal thing, but in general, people with money, higher socioeconomic status, have fewer health problems, or better health care, whatever you want to say. They generally have fewer health problems than those of lower income, lower socioeconomic classes, okay? Is that even the thing that's causing the health problems? No, we don't know, okay? Health is a very complicated thing. There's lots of things that affect health. In general, the general consensus is that access to health care is probably the biggest issue there, but that may or may not be the case. It's complicated. It's going to be the answer to pretty much all of these questions about life. But that's what's going on, okay? So in the same way, it's very clear that cigarettes is bad for your health. But if you just did an observational study and this is the only thing you have, just because this group of people smoked and they have more health problems and this group of people don't smoke and they don't have health problems, if that's the only bit of data you have, you cannot draw a cause and effect conclusion that this condition is good and this condition is bad. Okay? So observational studies, you cannot draw cause and effect conclusions. It's only when you do an experiment and you assign conditions to your subjects, whether they are people or lab rats, and the people don't get a choice, okay? You say, this group is doing this and this group is doing something else. That's the only time you can make cause and effect conclusions, okay? The book goes into more detail. It talks about placebo and blinding and all of these other things that go into experiments, okay? So experiments, you want to keep the two groups as similar as possible with the exception of that treatment. And that way, when you observe a difference, you can say, everything else about these groups are the same except for this one thing. And that's what makes the difference. Okay? Because with the other thing, with the Mercedes-Benz and the cheap cars, if you look at the two groups, these two groups are probably going to look very, very different. Okay? It's not just that the cars are different, it's a bunch of other things about their life are also very different. Okay? And so it could be any of those other things that are causing the difference in health issues and things like that. Alright, so I'm going to just write up a couple bullet points based on that spiel up on the board. And I leave it to you in your reading to fill in the rest of the information. Observational studies. Experiments. Over here. Assign treatment conditions to the subjects. We want all subjects to have similar conditions except for the treatment. we see the difference at the end of the experiment. We can say it is a cause and effect. Observational studies, we just observe, take measurements, cannot make cause and effect conclusions. An observational study only. Okay, I'm gonna change your homework assignment for this week. And I think the homework assignment currently assigns problems from Chapter 1 and Chapter 2, Sections 1 and 2, but I'm going to switch it up to Chapter 2, Sections 3 and 4, or just Section 3, okay?
Are you going to put that online?
I will make all of the updates online, okay? I'll update the problems online and I'll switch it around. But if you, I don't think anybody did this, but if you went on the website right now and you wrote down the problems, it will be the wrong problems, okay? So I'm going to update it tonight. So if you check tomorrow, it will be updated, okay? And it will be from Chapter 2, Section 3. Alright, so we have about 18 minutes left. I try to end as close to 10 o'clock as I can. Every now and then I might go a few minutes over, or I might finish a few minutes early, okay? If you have a ride situation where you've got to be out of here exactly at 10, just dismiss yourself, and that's fine, okay? Let me pass this around. This is the roster. Just sign your name, okay? And we'll do that. Okay, so just make sure you sign that before you leave. Okay, so this is going to be Chapter 2. Section 3. I will do Sections 1 and 2 next week. Okay, this writes about visualizing variation in categorical variables. Okay, listen up, you guys. Please be quiet. someone's talking over there and it's...
Weird.
Okay, so think of a categorical variable. Alright, so earlier in this class we had several different categorical variables, okay? One of them was, do you own a cat? Okay. Alright, another one was your gender, male or female. These are examples of categorical variables. Another one was hair color. Okay, these are all different categorical variables that we talked about. Okay, so let's say we wanted to summarize one of these variables. Okay, so let's summarize the cat variable. Do you own a cat? How can I make a summary of this thing? Well, we're just going to say how many people said yes and how many people said no. Alright? And we had a total of 84 people, and so maybe 22 people said yes, and so that means 62 people say no. Okay? I guess you can say this is the answer and the count. Is that fair as a summary table of our data? Yeah? Okay. Let's say we asked, let's make a summary table for gender. So what would my rows say? Huh? I would have a row for male, and I would have a row for female. And 84, let's say we have 41 and 43. I'm making up these numbers, okay? I don't know. Maybe that's right. We have the gender and the count. Okay, so these are summary tables. Okay, or these are also known as frequency tables. And we could have a display called a bar chart. So the bar chart, across the bottom, we will have our categories. We have yes, and we have no, and on the side we have the count. This will be 10, oh shoot, 30. I gotta redraw my thing because I'm gonna run out. Well, let me just erase this. Yeah, I'll fix it. Okay, so yes, it looks like this. I've got a bar that's 22 units high. And no, I've got a bar that's 62 high. Okay, so that's the bar chart. And if I make a bar chart for male and female, here I have a bar that's 41 units high, and over here I have a bar 43 units high. that okay? Making the summary tables, making the bar charts, we understand what's being displayed and the information provided here. Okay. So if I asked you which variable shows more variation in the answers, would you say the cat variable or the gender variable? So which variable has more variation in the answers? Okay, well, it's a good thing I'm teaching you guys, because the answer is the gender variable has more variation. Okay, so which variable shows more variation? The answer is the gender variable. Now, why is that? Okay, well, let's think about what variation is. Okay, I understand why many of you would have said the cat variable, because it looks like this bar is short and this one is tall, so that seems like we've got variation, right? We've got a short one and a tall one. That seems more like there's variation because these two bars, they look like the same height. Okay? When it comes to a categorical variable, it's good to see variables that are similar height. It's not good to see one bar dominate the thing. Why? Okay? Because if you were to blindfold me and we were to randomly pick a person, it's very likely, or there's a good chance that this person is male or a good chance that this person is female. Okay? It's almost like a 50-50 toss-up. Okay? Not exactly that, but it's pretty close to that. It means there's a lot of variation in the gender that we have. Okay? In terms of cat people who own cats, there aren't as many people who own cats. Okay? Just imagine if we flip this around. Okay? Let's say this is the gender difference in our classroom. We've got 41 males and 43 females. Okay? All right. Let's go on a submarine. Okay? And we ask, are you male or are you female? What are we going to see? Okay. So submarine in the Navy. Okay. Nobody knows what I'm talking about? Alright. Okay, so a submarine is this thing that goes underwater, and people live on there, and they live there for like 6 months. They can live like really long because it just recycles your urine and turns it into water, and you drink that. And it's like nuclear powered and all of this. And guess what? Everybody on the submarine is a dude, okay? And it's because it's too expensive to have separate living quarters for the females, and they don't want to have guys and girls in the same room because they don't trust you or something. So anyway, if you imagine the bar chart there, female, we would have basically a 0, and for male, it would be everybody. Okay? Is there much diversity in the submarine? No, there's no diversity. Everybody is a male, okay? We could talk about, okay, so maybe not so bad as a submarine, but if we go to, Not the mall. Let's say some, like a mining town, okay? So if you go to a mining town, you're going to have a high population of males, maybe a few females, okay? But again, your chart over there is going to just have a few females and lots of males, okay? Is there much diversity in the mining town? No. A little more diversity than the submarine, okay? Because as far as gender goes, we have a few females, but compared to this classroom where there's about an even number of males and females, okay, you're not going to get, in terms of, as far as gender goes, you're not going to get much more diversity than having a 50-50 split, okay? Same type of thing if we were talking about hair color, okay? If we look at the different hair colors in a classroom, okay, in the United States, we have a good amount of diversity in terms of hair color. We've got, let's say, we have blonde, we have brown, black hair, and we'll say other, okay? So people who might have dyed their hair or have red hair or something like that. Let's just say these are the categories. So in the US, you might have something that looks like this, okay? That would be a decent amount of diversity in terms of hair color, okay? Imagine going to China, okay? What do you think the bar chart for hair color in China is going to be?
Black.
Yeah. Almost everybody's going to have black hair, all right? Maybe you have somebody who has dyed their hair another color, and maybe you have some people who have dyed their hair lighter shades, okay? Because people can do that. But in general, you're going to have a whole bunch of people with black hair, okay? And so if we talked about diversity in hair color, so China would have less diversity, and their bar chart would look like this. USA has more diversity. USA, okay? So when we're talking about a categorical variable, and we're talking about variation in a categorical variable, we want to see categories having similar counts, or basically we don't want to see one category be dominant in terms of the field. Does that make sense? Okay? Summarizing categorical distributions. That's what we have. Okay, so you have sections 2.3 and 2.4 to do in your homework, and I will update your homework assignment as well. Okay? I look forward to having you guys this quarter. I'm looking forward to a great quarter, and we'll see you guys next week. Thank you.
What are the weighted assignment paper?